Hello, everyone. My name is David Stein. I'm an engineer at LinkedIn, and I will be telling you all about Feathr together with my colleague Xiaoyang. And yeah, we'll get started. Okay, so Feathr is the feature store that we've been building at LinkedIn for about 6 years. It's supporting a large number of ML use cases at LinkedIn, actually most of our ML use cases at LinkedIn. It is open source as of this past April, and we have a deep collaboration with our colleagues at Microsoft Azure. And together we've set up good support for Feathr on Azure. And we also recently announced that Feathr has joined Linux Foundation, AI and Data. And so we're thrilled to get to talk to you today about this exciting project that we've been working on. So for the agenda here, you've probably all already know and can see from the different talks so far today, there are a lot of different solutions in this space. There are a lot of different ideas around what feature stores are supposed to be. And so in this talk, we're going to focus, at least for the first part, on some of our ideas behind Feathr and feature stores, and how we think about feature stores. We have been doing this for a while, and we've deployed it for a lot of cases, and we've seen a lot of things. So we wanted to share why we built Feathr, what we think a feature store should be, and we'll also talk about how Feathr is used at LinkedIn, and also how Feathr can be used on Azure, and we'll have a demo for that. Okay, why we built Feathr. So to summarize, getting features into ML models should be easy. Should be easy. Getting features into ML models should be easy. There's obviously a lot more to feature stores than just this, but I think this is like the core item. When we started, it was not easy to get our features into our production machine learning models. The goal of Feathr is to make that easy. And I'll talk about this thing that many folks may not be expecting as the next thing to say. I want folks to think about music streaming apps like Spotify or Apple Music. And you might be wondering, like, what do music streaming apps have to do with feature stores? I would argue that there's an analogy that is actually pretty good, that I think conveys the way that we think about what feature stores should be and should become. Anyone who is old enough or has been around for a while listening to music probably remembers, like 10 to 20 years ago, what it was like listening to music before the age of the music streaming services. And in my experience, it was something like this. You would have to go manually get your music files from various sources, various sources, convert them into a format that your particular device you want to use can play. You need to load them onto your device, which may be different depending on the context. And then you need to worry about a bunch of things like whether you have enough storage and whether the bitrate is any good and that the quality will be good, about compatibility. And that was what we had to do all the time, like in the early 2000s. And now we just ask the virtual assistant to play the song. So I was thinking about this the other day. It's like we have solved this problem in the industry. So it's like, congratulations to Spotify and Apple Music and their competitors. We kind of have made this easy for humanity. You can just like ask the virtual assistant to play your song and you just get it. And the analogy here that you maybe by now can guess is that the sorts of complex workflows we saw for getting features into ML models at LinkedIn before Feathr were kind of similar to this. You have to write jobs to get your entity data from various data sources. You have to convert and extract, aggregate, join into whatever the format is that your inferencing engine and training system needs. You need to actually then load your data into the model framework, which may be different from training and serving. You have to worry about scale, performance, leakage, training, serving, scoop. We want to change that, right? We want it to be like, you just import the feature by its name into your model code. And then if it doesn't exist yet, you just define and register it using a simple API. So we want feature stores to become like the music streaming app of data dependencies in machine learning. So this hopefully kind of illustrates the challenge we observed and why we built this. Feature preparation at scale with lots of entity features that need to be fetched and joined is really complicated. We're hearing about this a lot in the various talks. There are a bunch of things that need to happen. I don't know if you can see like what I'm pointing at with like my mouse here, but we have raw data, we have users, basically everything in this circle used to be like what individual teams would have to focus on as a large part of their work to do production machine learning at scale. And that's a lot of complexity that ideally you want your ML teams to be focusing on actually the modeling and on the feature engineering. So we replace that like this. You have, your feature store as your kind of common data layer between, kind of unifies the training and the inference service contexts, and makes it so that you can just define your features and then get them by name and not have to worry about all of that stuff anymore. Another way to think about what the feature store is I like to think about it like a package manager, but for machine learning. The section at the left that everyone sees something like this at the top of their Python code, it's like, it's hiding a lot of complex stuff actually. So the era before we had nice package managers and libraries and software engineering, I wasn't really that aware of it, but from what I understand, like going to have to manually get all of your dependencies and link them together is hard. It's easy what we have today, where we can just import the packages. And this is how we envisioned the role of the feature store. You can just import your features into your model code and use them. So for time, I guess I have to kind of hurry up here. So this is sort of speaking to what a feature store should be. The principal use cases of the feature store are to develop features based on the raw data using simple APIs, deploy features for training and for online model inferencing, and then to be able to manage features, and monitor them, and share them across teams. So we break it down in this way. Even the term, the feature store, the way that we think about how this should look is there are producers and consumers of features. The abstraction kind of works like you put the features in, you define features based on raw data sets, or sometimes based on pre-computed features from other systems. You have a set of primitives and tools that you can use in order to define the features. And you can also define or develop features based on other features that are already present in the feature store. And then you get features out, which is kind of like I'm talking about, just getting them by their name, but with all of the details around how that is supposed to work in the training and inference contexts, just figured out for you, like backfilled point-in-time correctness for training and to be computed and stored for efficient retrieval for online inference. Getting a little bit to Feathr at LinkedIn. Feathr is one of the pillars of LinkedIn's machine learning platform. A kind of motivating picture, I think, of how Feathr is used here is at LinkedIn, we have a training orchestration platform that has been discussed in some LinkedIn engineering blog posts, where users can write model training workflows, basically, that produce models on a scheduled basis or on an ad hoc basis and can load them into a model registry for deployment into online and production. There's a human that gets to then push a button to deploy models into the production inference services. And there are safety mechanisms, just as one kind of important example of how the feature store is used, that checks to make sure that the model's feature dependencies are present. And then if they're not there, you don't allow the deployment, right? You want to make sure that the data and the feature definitions and the metadata are deployed first, so that you can know that the model will be able to run in the inference service safely. So a lot of what happens is we're making it so that you can drive most of the machine learning development and deployment process without having to really change any of the code or any of what's happening at the inference service, at least in the ideal scenarios. A little bit more about Feathr at LinkedIn: hundreds of models, thousands of features, many kinds of entities. LinkedIn has written a lot about the economic graph and petabyte scale. Our timeline: we initially proposed the project in 2016. We've been building it really in earnest since 2017. Broad and then like majority adoption within LinkedIn by 2020. And in 2022, open sourcing. We have the Azure collaboration and joining Linux Foundation. I want to make sure we have time for the demo, so I'll probably go through this stuff really quickly, but we also talk about this in the blog post. We've seen improved productivity from faster experimentation with new features. We cite from weeks to days. There's improved performance. It's interesting. There usually is like a tension between abstracting over things and actually optimizing them to make them faster. Usually what I think we kind of hear in the industry, right? If you are adding abstractions, you're risking that something can get lost in the middle, so the performance may not be as good. But we actually found that using kind of the automated feature pipelines that are produced by Feathr, it's much easier to optimize those most of the time, because the large set of manually crafted join jobs for a particular team, would be very difficult to keep optimally running. So the general solution that we have in Feathr has been outperforming those that it replaced. And it has also improved collaboration, made it easy for similar projects to be able to use similar features, whereas in the past that used to be much more complicated to do. I'm now going to hand it over to Xiaoyang to talk about Feathr on Azure.
Before I actually talk about the demo, I really want to talk about the architecture for Feathr. So as David said, we built a lot of connectors for the cloud services to make it more enterprise ready. So Feathr is integrated with Azure and also with AWS. So here's the architecture where a user comes in. There are two sort of interfaces that users can expect. One is the Feathr UI, where it's like a web portal, and the users can explore all the application, all the features registered, all the projects and the entities. They can also explore, they can also manage all the access control, which I'll introduce later. After that, they can also go through all the Python client to actually define the features and to get features from different registry, and to reuse all the data and features from different sources. Currently, Feathr supports different offline stores, such as like data lake type storage, for example, like Azure Blob Storage, Azure Data Lake, S3, or like Databricks, or those kinds of data lake specific format. Feathr also supports tabular sort of offline store, for example, like SQL databases and SQL data warehouses and Snowflake. Aside from that, Feathr also supports like streaming sources, Event Hub or Kafka. All the features can be streamed through that and put that into Feathr. And after that, Feathr will do a centralized compute, which is based on Spark. Currently, Feathr supports Databricks and Azure Synapse, so you can use all of those Spark services to compute all the features. And then you can also materialize the feature to online stores such as Redis or Cosmos DB, depending on your IT setup. And then you can retrieve all the Feathr features from like a Jupyter Notebook environment, from like Kubernetes, and from different environments. Aside from that, Feathr also, because Feathr is enterprise ready, so it also supports like enterprise like key value systems, for example, like Azure Key Vault to store your secrets, as well as like AWS Secret Manager. That's for the major workflow. And for the Feathr UI, basically we have like a REST API, so user can either call those API directly, or they can interact with the API through the Feathr UI. And on the backend, it's the feature registry, which is based on Apache Atlas or SQL Server. That's sort of the high-level architecture for Feathr. And then let me jump into a quick demo. So the first step is to provision all the resources for Feathr. So there's a long documentation for that. I'll just skip that. Basically, the key idea is to run through a couple scripts and hit this button called deploy to Azure, and we will provision all the resources for you. So after that, you should be able to see a Feathr UI. And in the Feathr UI, you can explore like there's a home page. You can explore different projects and different data sources. For example, I have a couple projects here where I can see I have registered a couple, and then I can also take a look at all the data sources for different projects. And then the most important thing is to see the features. For example, I want to see all the certain features in a certain project. In that case, I'm going to this feature page and look through all the features that's available. And what's nice there is that I can also see the lineage of the feature, so that I know that's where this feature comes from and how this feature they are derived. As I can let me just show that real quick, so that I can see that in this project we have a couple of sources like the purchase history data and the product profile data and the user profile data. And then we have a couple of we call it anchor features, which means the base features where it's defined directly on the source. In that case, we know that there are a couple features called the total purchase for a certain customer in the last 90 days. We know there's another feature called the product quantity. And then what's nice in Feathr is that because Feathr really encourages feature reuse, so we have a concept called derived feature, where you can define features on top of others features. In that case, I know that there are base features, and then there's also derived features called users purchasing power, where it's based on the definition of this feature is based on those two prior defined base features, which is like gift card balance and whether the user has the valid credit card or not. I can also explore the definition of the feature, so that I know that this feature called user purchasing power is defined by the user gift card balance feature plus whether the user has a valid credit card or not. So after all of those, as a feature consumer, I'm very confident that I can reuse those features. But before getting into the details on the Python scripts, let me also show that Feathr also has enterprise readiness, which means that Feathr has RBAC control built in. Basically, everyone can manage, IT admins can manage all the features in your feature store in a role-based access way. In that case, you can see that there's a web page called management, and you can see the different roles here. For example, you can see like as an admin, I can manage all the features for all the systems, and someone could only have access to like a single feature or single project, and that's supported. And folks can also we can also make sure that folks only have read access or write access, just to make sure that Feathr is enterprise ready and all of those features they are protected by the access control system. So going back to the feature consumer. So after we've seen all the derived features and base features that we've defined, so as a feature consumer, the thing I want to do is that I really want to consume those features. Because as a feature consumer, I know that I'm working on this table where I have a couple of observation data that I care about. I have user ID, I have product ID, and I have a couple of feature tables, such as the user profile data and the purchase data and the product data. That's all of those, they are available in the UI, and I just want to use those. So the first step is to, of course, install Feathr and import all the packages there. So after that, because Feathr adopts open architecture, and you need to specify which kind of endpoints you are trying to use. For example, I'm using Synapse here, or I'm using Databricks here. I just need to specify the endpoints for those systems. And because Feathr use Key Vault or those kind of cloud-based secret management system, so you actually don't have to put the password there. All the passwords, they are stored securely in your secret manager, and you can just you don't have to store all the you don't actually need to store the password here. So after that, I specify a couple of settings for the endpoints and initialize the Feathr client. So I want to explore the data set a little bit. So I want to read the data from in pandas and take a look at the user ID and product ID and a couple other columns. And then take a look at all the other feature data, like the gift card balance, or the purchase date, or the purchase amount, and the category, and the state. So the first thing for Feathr is that we actually let me switch to the consumer demo.
Sorry, Jae-Yoon, can you move through this quickly, because we're kind of out of time, so you have to kind of just go through the main parts, I guess, very quickly.
Sure. So what you need to do as a feature consumer is that you just need to call this API called get features from registry. So you already explore the UI, and you just get the feature by their names based on what David just talked. So it's like a streaming app. So you just call the features by the name, and then Feathr will kick off a job with this API called get offline features, and you can just download the featureized data here. And in that case, you can see that we have user ID and product ID, and we have all the features that we just want to retrieve from the feature store. We have the total purchase, the product price, and everything here. And after that, you can train a machine learning model. And then you can just after you feel comfortable with the features, you can just materialize the features into an online store. In that case, you materialize those two features by their names, the user's age and the gift card balance. After that, you just call this API, which is get online features. And in that case, Feathr will just retrieve the features by their names in the online storage. In that case, you can see that we are getting the features for customer 1 and 2, and get their features correspondingly. Of course, you can define the features in a more Python way. Due to the time constraints, I will just skip that. But basically, you can define the features based on their windowing, aggregations, and based on the point-in time correctness. So all of those resources, they are available in the Feathr GitHub repository. So feel free to check it out.